Hi guys, so welcome back to LeetCode with AK. So guys, actually today we are going to discuss about a LeetCode daily challenge, and the problem is really very interesting one. And end of this video, actually one of the hidden secrets is getting revealed for the binary search. So please stick with me till the end. So we are, as usual, we are going to discuss about the both brute force, optimal, as well as end of this video we are going to discuss about the time and space complexity. Please stick with me till the end. Okay, let's move on to this problem statement. Okay, actually the problem statement was categorized as a medium. Okay, the problem is really very easy. So only thing is like you have to read the problem statement twice and understand what all the things is being given in the problem statement. Okay, let's read this problem statement. Actually what you have to do, you have to find the peak index in the mountain array. Actually they will give one array, just consider as a index of the mountain. Okay, what you have to do, you have to figure out the peak index value in that mountain array. So okay, let's say then ask one question. Okay, how the index is a peak? Okay, how the index is a peak? So for that they are given the two conditions. So if a particular index is satisfying that two conditions, then definitely the index is going to be a peak index value. Okay, so first what they are trying, the I, so the I should be greater than 0. I mean your index should be greater than 0 as well as less than the array length minus 1. Okay, in that case, okay, let's say your array as of 4. Okay, your array as of 4 value 1 2 3 4. Okay, in that case what they are trying to say, okay, your peak index should resides between 0 and less greater than I, and I should be less than array length minus 1. Okay, so definitely your peak index going to be reside somewhere here. Okay, so please first read a very the condition is given in the problem statement, and then we will move forward. Okay, what is the second and third condition? Okay, all previous elements, so which means if array of I, okay, just imagine, okay, 0 1 2 3 4. In that case what they are trying to say, okay, if this is the I, in that case all previous elements should be less than your current index value, as well as all the subsequent values should be lesser than. So which means your index value should be greater than for all previous element as well as all subsequent element. In that case your current index going to be a peak. Okay, so two conditions please keep in reminder. Okay, if the index is a peak, okay, then all previous element, then all subsequent elements should be lesser. Otherwise actually we are just declaring as the index is a peak index. Okay, so you must solve this problem using O of log and time complexity. Okay guys, so with the actually the request from my side, please don't worry about the time and the space complexity the very first time. If you're reading the problem statement, please try to grasp all the input is given in the problem statement and try to understand how to solve this problem using the brute force approach, and then just think about how to optimize this approach. Okay, as of now, please guys, please don't worry about the time and space complexity here. Okay, we are going to write for both brute force as well as the optimized approach. Okay, don't worry about the time complexity as of now. Okay, so I will ask one question. Just okay, now you guys understand about what is the peak index value. Okay, so just take one input statement given in the LeetCode, 0, okay, 0 2 1 and 0. So just actually, so I just request you guys, please just consider you're just climbing the one mountain. In that case I will ask you one step. Okay, please reach the peak index position in that mountain. Okay, while you're climbing the mountain, so what you will do, if my current you will check your current altitude, right? Because the aim is you have to reach the peak. Okay, in that case please you have to check with your current altitude as well as your subsequent altitude. Okay, so there is a two possibility. My current altitude definitely going to be greater or is going to be lesser. If my current altitude is greater, okay, so what will be the case? Okay, your current index could be a peak index. If your current current altitude is really lesser than the subsequent altitude, in that case what you will do? Okay, as of now I am staying in one altitude which is really low compared with my next step. Okay, so in order to figure out the altitude, I will move forward to figure out the peak index. So there is a two possibility. Please check your current index value as well as the subsequent value. If your current index value is really greater than the next subsequent values, then definitely it's going to be a peak index value. Otherwise, so what you have to do, you have to just move forward to figure out the peak index value. Okay, just draw one mountain. Okay, this is 0, this is 2, and this is 1, and this is 0. In that case, so just take 2. Okay, just take 2. Okay, I will ask one question. They did all the values, all previous values is really greater than 2? Yes, all my previous values is really greater than 2. Okay, fine, it's satisfying very first condition. So what is the second condition? Did all the subsequent values is really greater than 2? Yes, my all the subsequent values is really greater than 2. Okay, then just declare the value 2 is going to be a peak value. So in problem 7 they are clearly mentioned they don't want to return the peak value, we have to return only the peak index. Okay, so in that case, what is the index for 2? The index for 2 is a 1, so you have to return 1. Okay, now guys, you understand about both the problem assessment as well as the test case. Okay, then how we are going to solve this problem using the brute force? Okay, every time you have to check the current index value as well as the subsequent value. If my current index value is really greater than my subsequent value, okay, in that case this is a peak. Otherwise, you have to move forward to check if my current index value is really lesser than the subsequent value, then move forward to check the peak index value. Okay, so pseudocode is like, so what you have to do, every time actually you have to check the current index value. Okay, current index value is lesser than, sorry for my handwriting, in that case, okay, there is a possibility, just increment the index to figure out the next, find a next possibility to figure out the peak index value. So this is the way actually you are to going to figure out. Okay, just write this problem. Okay, just solve this problem in brute force way. So already I written the code. So what I did, I just declare one index value, and then I am trying to check my current index value is really lesser than my subsequent value. In that case, please move forward, because already one index value is really greater. Please move forward, and I will incrementing the index, and finally I am return the index value. In that case, so every time you keep on iterating to figure out, okay, my current, check your current index value and the next subsequent value. If my current index value is really greater, please return. If not, please move forward to figure out the next possibility. So this is what actually you are going to do in brute force approach to figure out the problems. Okay, so finally you are just returning the index value. Okay, so what is the time and space complexity? At the worst case, just think about the worst case. In that case, in worst case, actually you have to iterate all the element in the given array. So definitely the time complexity would be O of n, and space complexity would be O of n, because I am not creating any array, I am not creating any hash map or asset, nothing. So the time complexity for brute force approach, the time complexity would be O of n, O of n, and the space complexity would be O of 1. Okay, O of n, and the space complexity would be O of 1. Okay, so in problem set 1 they clearly mentioned you should solve in O of logarithmic of n time complexity. Okay, so guys, I will tell you this problem can be solved by using the binary set. Okay, and a very next question actually you will ask to me, okay Aravind, I can solve this problem using the binary set. Okay, did the array is sorted? No, array is not sorted. Okay, so what if the array is not sorted, then how we are going to solve this problem using the binary set? So guys, I said during while I starting this video, I said, right, one of the hidden secret of the binary set is getting revealed today, right? That is the what. So binary set can be applicable for both sorted array and unsorted array. So if anyone asks you, did binary set is applicable for unsorted array? Yes, binary set is even applicable for unsorted array. Even for few problem, if the given array is unsorted, you no need to sort. Just you can use binary set to figure out a problem. So please keep in one mind, binary set is applicable for sorted array, as well as the binary set even can be applicable for unsorted array. If anyone said, okay, what is the example for unsorted array, please tell this problem. This problem can be solved by using the binary set, even though the array is unsorted. Okay, then how we are going to solve this problem using the binary set? Okay, normally in binary sets what we will do, we every time actually we will figure out the mid index. Okay, so let's say again the same problem, 0, 2, 1 and 0. In that case, okay, every time, so what you will do, you will figure out the mid index value. Okay, again same, what you have to do, please check your mid value with the next subsequent value. If your next subsequent value really greater, okay, please move forward. If not, okay, come back. Okay, already you are in one particular position. Let's say, okay, you are taking this array. Okay, no, this is 1. Okay, this is 1. Let's say if you are in 1, okay, just check if 1 is really greater than 2. No, definitely not. 1 is definitely not greater than 2. Okay, in that case 1 is my mid. Okay, so what I am saying, okay, you are staying in mid position, but the subsequent element is really greater, so I will tell, so please move forward, because there are one nice possibility available in nearby index. Please move forward. So in that case you will now you are standing with 2. Okay, the 2 is really greater than 1. Yes, my 2 is really greater than 1. So what you will do, okay, I reach one index value. Okay, the subsequent value is really lower. In that case, definite, so might be my 2 could be the peak index or something before. I mean, if 2 is greater than 2, in that case you are in increasing order, so definitely 2 could be my peak index. Okay, what, please don't conclude. Okay, you just move forward, I mean move backward. There are some possibility. Okay, there are some possibility, you're just moving forward. So what you have to do normally, okay, so there are two things. Okay, if your mid value, okay, if your mid value is greater, if less than mid plus 1, actually you have to move forward move. Okay, if not backward. So how we are going to determining this one? So if this is mid, this is my left, this is my right. If my mid is really lesser than mid plus 1, you have to incrementing your L equal to mid plus 1. Okay, definitely there is something big in my next subsequent element, so that big could be my peak index. Maybe that something that is might bigger than value in another subsequent element. So I'm just, for safe purpose, actually I'm just moving my left towards mid plus 1. Okay, otherwise if my mid, just saying this is your mid, if your mid is really lesser than your mid plus 1, in that case, okay, I'm in increase order, so please shrink your array, shrink your right size. Okay, in that case, so what you have to do, just declare your r equal to mid. Okay, there are two possibility for forward move. You have to, okay, I'll just change the color. Okay, for forward, actually what I have to do, for left equal to mid plus 1. For backward, what I have to do, for r equal to my mid. Okay, so this is what actually I'm going to do. Okay, so I'm going to write a problem for this one. Okay, first, for finding the binary says, first what you have to do, you have to declare both left and right array. Let's say left equal to 0 and right equal to array dot length minus 1. Okay, so you have to iterate while my left lesser than right. So first please figure out the mid. So what is the formula for figuring out the mid? You have to do just mat.floor left plus right by 2. Why I'm using the floor? Because it will do round off. Okay, it will do round off. If I figured out the mid, so what is the two condition? Just check your mid is really lesser than your mid plus 1. In that case, please move forward. How we are going to move forward? You're just staying in one particular index. Okay, one particular index. Your index value, your mid is really lesser than next subsequent element. In that case, please just move forward. Okay, so your left equal to mid plus 1. Otherwise, my right equal to mid. Okay, finally return your left. Very simple. Okay, just run this problem. Definitely going to satisfy all the condition. Please submit. Okay guys, definitely all my test cases are going to be passed. Okay, I will ask one question. Okay guys, now guys, you understand about both problem statement as well as both brute force and the optimized approach. Guys, if you have any question, please ping me in comment. Definitely I will reply back to you, each and every one. And we are coming to the very final part of this video. So what is the time complexity for the binary size? A time complexity for the binary set is a O of log n. Why O of log n? In binary says every time you're trying to figuring out the mid, and then you're just discarding your left or you're just discarding your right. In that case, for every iteration your array size is getting shrink by 2 by 2 by 2. So in that case, your time and space complexity would be logarithmic of n base 2n. Because okay, what about the space complexity? I am not declaring any array as set or as map, so definitely my space complexity would be O of n. Now you just solve this problem in both brute force as well as in optimal way. Okay, so okay guys, that's all about this question. So guys, thanks for watching this one. Thank you so much for stick with me till the end. So guys, I will meet you on tomorrow. If you have any doubts or any clarification, please ping me in comment section or ping me directly in LinkedIn. Definitely I love to reply back to you. Thank you guys. I will meet you on tomorrow.